Pre-statistics. Using the slope of a line. Lesson objectives. Compute the slope of a line. State if the slope is increasing, decreasing, zero, or undefined. Lesson objective. Steepness. Consider the stretch of two cables. These are also known as guide wires running from the ground to a telephone pole. Which cable is steeper? Cable A or cable B? If we look at it carefully, we can see that cable B is steeper than cable A. To measure the steepness of each cable, we compare the vertical distance from the base of the pole to the top end of the cable with the horizontal distance from the bottom end of the cable to the building. So for A and B, they're both spanning a height of 16 feet. B's horizontal is half of A, so B is steeper. So when we compare the steepness of two objects, we want to compare the vertical distance to the horizontal distance. And this is known as a ratio, a comparison of two things, and whichever object has the largest ratio will be the steeper object. Let's do an example. Portion of road A climbs steadily for 120 feet over a horizontal distance of 4,250 feet. A portion of row B climbs steadily for 95 feet over a horizontal distance of 2,875 feet. Which road is steeper? Explain. The solution: first thing we want to do is sort of draw a picture to get a visual. So here we have road A. The vertical is 120 feet. The horizontal is 4,250. For road B, vertical is 95. The horizontal is 2,875. So if we calculate the unit ratio of the vertical distance to the horizontal distance for each, we have road A would be 120 feet over 4,250 feet. The feet will cancel, and if we take 120 and divide it by 4,250, we get something that's approximately 0.028. For road B, the vertical is 95 feet over horizontal, which is 2,875. Again, the units cancel, feet cancel, and we're left with 0.033 when we take 95 and divide it by 2,875. So we see road B is a little steeper than road A because the ratio is larger than this ratio. The grade of a road is the ratio of the vertical distance to the horizontal distance, written as a percentage. If you recall, to write a decimal number as a percentage, we move the decimal point 2 places to the right and insert a percent symbol. The reason for this is we are multiplying by 100. That's why we move it 2 decimal places, because that's what a percent is. It's what part of 100. In example 1, the grade of road A is about 2.8%, and the grade of road B is about 3.3%. So if you ever see this highway sign, what does the 7% mean? The 7% is what we call the slope of the road. It means the road drops 7 feet vertically for every 100 feet horizontally. The vertical is 7, the horizontal is 100. So slope is the steepness of the line. Here's an example. So the slope of this road is 26%, which means the vertical change is 26 feet to every 100 feet horizontally. Here's another real life example of slope. Here we have a house that is in New England, and if we look at the pitch of the roof, it is a lot steeper than the pitch of this roof. Now this house is from New Mexico. The pitch is more steep for this house because in New England you get a lot more snow than you do in New Mexico. And the larger the pitch of the roof, the easier it is for the snow to fall off the roof. If you live in New Mexico, you don't get that much snow, so you don't have to worry about the snow falling off. A lower pitch can be used. Let's define slope. Slope is denoted by M, and it is equal to the vertical change over the horizontal change. And if we think of this graphically, it's what we call the rise over the run. Now the rise is the change, and the vertical, the run, is the change in the horizontal. Now the way I keep it straight in my mind is you have to rise, you have to get up before you can run. So rise is going up or down, and run is going left or right. So in words, the slope of a non-vertical line is equal to the ratio of the rise to the run, going from one point on the line to another point on the line. So here we have a visual. So if we look from this point to this point, the rise is how far are we increasing on the y-axis relative to the change in the x-axis. So it's rise over run. Now if we're given 2 points, we do have a formula for slope. It is still the vertical change over the horizontal. The vertical change would be the change in the y values over the change in the x values. Now the reason why we have these little subscripts is once you pick your y coordinate from one of the 2 points, the x coordinate must come from the same order pair as this y. This x coordinate has to come from the same order pair as this y. Here's another visual. This is the Greek letter delta. In math, delta means change, so it's the change in the y divided by the change in the x. It's delta y over delta x. Let's do an example. Find the slope of the line that contains the points 2, 3 and 5, 8. So we're given 2 points, so we're going to use our formula. We're going to let x1, y1 be 2, 3, and x2, y2 be 8, 5. So this is our first point, this is our second point. Using our formula, we're going to take y2 minus y1, so that's 3 minus 5, and we get negative 2, over 2 minus 8, which gives us negative 6. Now negative divided by negative is positive, and we have 2 over 6, which reduces to 1 over 3. Now if we have graph paper and we plotted these points, 2, 3 and 8, 5, and we simply counted how much change vertically over how much change horizontally, we would get 2 over 6, which is the same thing as 1 over 3. So this again is the same result as using the formula. Example 3. Find the slope of the line containing the points. Now here we have fractions. We can use a calculator. Using my TI-83 calculator, I'm going to take negative 5 over 3 and subtract a negative 3 over 4. Now I need parentheses around all of this. So the numerator, you need parentheses. Then you hit divide and parentheses for the denominator, in this case, which is negative 2 minus 1/2. And we get 0.36 repeating. So if we hit our math key and enter for fraction, we see that it converts this decimal, repeating decimal, to 11 over 30. Thanks for watching.